What? All right. So, just as a refresher here, we are talking about the normal distribution. So it requires our data to be normally distributed. The mean is 28, standard deviation is 7. What do we have to do first on any of these problems? If you are looking on your formula sheet, your table gives you z values. So when we are looking at the normal distribution, we have to convert it into a z before we are able to look up our probability. If you have forgotten how to convert it into a z, it's on your formula sheet. Back under chapter 3, second column, kind of the bottom middle of that. It tells you your z-score is x minus mu divided by sigma. So my z would be my x, which is 28, minus the mean, which was 28, divided by the standard deviation. So what's your z? So we are needing to find the probability that z is less than 0. So if you look at the table, up at the top, it has a picture and it tells you it's giving you the area less than. So we have the z, so those are the bolded numbers down the side and the top. And we are looking up when z is 0, so that would be 0.0. And we get what probability? 0.5. It's the same, yeah. All right, B. What do we have to do? Okay, get both of the z's, then we're going to subtract. So x minus mu divided by sigma. So we need to find the probability that z is between 0.29 and 2.43. So to do that, we know our probability has to be a positive at the end. So to get the between, we're subtracting. You have to do the bigger one minus the smallest one. So you look up the 2.43 first, and that probability is 0.9925. Then we subtract off the 0.29, which is 0.6141. Subtract those and we get 0.3784. Let's see. Again, change it to a Z. We always go to 2 decimal places, round accordingly, so 2.86. So we need the probability that Z is greater than 2.86. How do we do greater than? Okay. So 2.86 gives me 0.9979. And so that is 0.0021. So on these, you first always have to change your x into a z. Then you read your probability from the table. It gives you less than. So if it's less than, it's just your probability. Greater than, you do 1 minus. Between 2 values, we subtract. Are those okay? What if I asked you, I don't remember what else we had. The Z alpha notation. So if I said, what does that notation mean? Saying on your normal curve, this 0.15 is this area to the right. Your table gives you area to the left. So what probability are we looking for on the table? So we have the probability, we are looking for the Z. So you're looking inside the table. The closest we can get to 0.85. So 0.8508, which is at 1 point. Are those okay? Yeah. Let me do one last question. Find the z-scores that contain the middle 92% of the distribution. Okay, so when I'm asking for the z-scores, I'm asking you to find the z values that contain the middle 92%. So that means there's 2 of them. 92% falls in the middle. You have to tell me what those z's are. Alright, if 92% is in the middle, how much do we have left over for these ends? Right, there's 8% left, you have to split it up over 2 ends, so each of them gets 4%. So this is 0.04. So if you look up on your table, if the probability is 0.04, so that is the number inside the table. Closest we can get to 0.04 is 0.0401. It's a negative 1.75. So what's this number going to be? How do you know that? They're symmetric. If you didn't, for this end, 96% is less than. So if you went and found 0.96 inside your table, the closest you can get is 0.9599, and that z is 1.75 as well. So either way. Is this okay? So today, this stuff is very important. We will use this normal distribution for the rest of the semester. So we are going to take one more day and practice it. I just have a handout for you. So we've done a little bit of review. We're just going to practice a little more. Tomorrow we will start chapter 8.